Hello friends, welcome to our channel Anand Academy of Education. Today we are going to start a new chapter in mathematics, theory of equations. Theory of equations. This chapter is a very easy chapter and there will be at least one question from this chapter for intermediate, EAMCET or JEE mains, advanced or any other state engineering entrance examination. So I request you to kindly listen to this lecture thoroughly. And this is our first lecture and I will teach you this lecture in a way that you can be able to crack intermediate, EAMCET or JEE mains, advanced or any state engineering entrance examination. So let's start our lecture. So the first and foremost thing is to know what is an equation. What is an equation? This is the fundamental thing that we need to know. What is an equation? So an equation is nothing but a statement that involves an equal to sign. It is as simple as that. So equation is nothing but anything that involves an equal to sign. So if something involves an equal to sign, then it becomes an equation. 5 plus 5 is equal to 10. This is an equation. 2x minus 1 is equal to 0. This is an equation. 3x square plus 5x is equal to 35. This is an equation. Because in all these, there is an equal to term. There is an equal to sign. And so these are all equations. Because they involved an equal to sign. So these are all equations. So in this chapter we will be studying about these equations, studying about different types of equations and their nature, their characteristics and their nature of roots, etc. So is this an equation? 2x minus 1 greater than 0. Is this an equation? No, because this does not involve an equal to sign. We don't have an equal to sign here. What we have is greater than sign. So this is not an equation. But this is an expression. This is not an equation but an expression. Likewise, x square minus x less than 3 is also not an equation but an expression. So equation is something that involves equal to sign. So if it does not involve equal to sign, then it will not be an equation. So first, linear equation. What is a linear equation? So in the last two slides we had seen what is an equation and what is not an equation, and now we are slowly going into the types of equations. So the first one, linear equation. What is a linear equation? A linear equation is something that has the highest degree of 1 in the variable term. So the highest degree of the variable term is 1. So we can just represent this linear equation in the form a1x plus a1x1 plus a2x2 plus a3x3 plus a4x4 and so on, anxn is equal to 0. this is the form of a linear equation. Here, the highest degree of the variable term. Here we have many variable terms. x1 is a variable term, x2 is a variable term, x3 is a variable term, and so on. We have xn variable terms. But the highest degree of all these variable terms is 1. The highest degree of all these variable terms is 1. So we call this as a linear equation. A linear equation is something that has the highest degree of 1 in the variable term. So this variable has highest degree of 1. This variable has highest degree of 1. So not the variable term, sorry, highest degree of variable. Highest degree of variable. Highest degree of the variable. I'm sorry, not the variable term. So variable term comes, so this is all the variable term. This is the variable term. So highest degree of the variable. Highest degree of the variable. Not the variable term. Highest degree of the variable. So x1 is a variable. Its degree is 1. x2 is a variable. Its degree is 1. x3 is a variable. Its degree is 1. x4 is a variable. Its degree is 1. xn is a variable. Its degree is 1. So the highest degree here is the highest degree of the variables here is 1. And so this is a linear equation. This is a linear equation. Ax plus b is equal to 0. Ax plus b is equal to 0 is a linear equation in one variable. Is a linear equation in one variable. Here we have n variables. Here we have n variables. So if we just take one variable, here we also have a constant plus b is equal to 0. Let me write this here. a1x plus a2x2 plus a3x3 plus a4x4 plus and so on plus anxn plus b is equal to 0 plus b is equal to 0. So this is the form of a linear equation. This is the form of a linear equation. This is a constant term. We call this constant term. Constant term or absolute term. Sometimes we call this as absolute term as well. So this is the variable. x1 is a variable, x2 is a variable, x3 is a variable. So we have n variables. But if we only take one variable, if you take an equation in one variable, then it looks like this. Ax plus b is equal to 0. Ax plus b is equal to 0. And here a should not be equal to 0. A should not be equal to 0. Because if a becomes 0, then this whole x term becomes 0. So we will have b is equal to 0. So which is not a linear equation. So here a should not be equal to 0. And this linear equation in one variable has a unique solution. X is equal to minus b by a. This is the solution here. This is the unique solution. Likewise, ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0. This is a linear equation in two variables. So here we have the variable x and the variable y. So these are two variables. So this is a linear equation in two variables, and the highest degree of these two variables is 1. So this is a linear equation in two variables. And this is also the standard form of a straight line. If we can represent this equation in a graph, then it would be a straight line. Ax plus by plus cz plus d is equal to 0. This is a linear equation in 3 variables. So to sum up all our points, a linear equation is something that has the highest degree of 1 for its variable. So the variable's highest degree is 1. It should not be greater than 1. Now, second one, quadratic equations. Quadratic equation. What is a quadratic equation? In the last slide, we have seen linear equations, and we learned that linear equations highest degree is 1. The highest degree of variables is 1. But in quadratic equation, the highest degree of the variable is 2. Not the variable term, but the variable. The highest degree of the variable is 2. Ax square plus bx plus c is equal to 0. Ax square plus bx plus c is equal to 0. So this is the standard form of a quadratic equation. So here the highest degree of the variable term, highest degree of the variable x is 2. We have the variable, we have the power of variable of 1 as well, but the highest power of the variable is 2, and so this is a quadratic equation. And we call a and b as coefficients. And c is constant term. A is coefficient of x square. While b is coefficient of x, and c is constant term. And a should not be equal to 0. Because if a becomes 0, then this becomes a linear equation. So for a quadratic equation, the coefficient of x square must not be equal to 0, because if it becomes 0, then it becomes a linear equation. If it becomes 0, then it becomes a linear equation. So here if a becomes 0, it becomes a linear equation, or a constant term if b is also 0. Now quadratic equations are of two types. The first one, purely quadratic equation. So what is a purely quadratic equation? Here we don't have the x term. This implies ax square plus c is equal to 0. So this is a purely quadratic equation, because the x term, this term is absent here. So we call such type of equations as purely quadratic equations, because they don't have x terms. Likewise, adfected quadratic equation or complete quadratic equation. This is also called as complete quadratic equation. So a complete quadratic equation is an equation that has both x term and x square term. Ax square plus bx plus c is equal to 0. So this is an adfected quadratic equation or complete quadratic equation, because we have x square term and x term. So this is an adfected quadratic equation. And a, b and c can belong to complex number set. A, B and C can belong to complex number set. So A, B, C can take the values of complex numbers. Standard quadratic equation. We have just seen in the earlier slide two types of quadratic equations. The first one, purely quadratic equation. The second one, adfected quadratic equation. So this adfected quadratic equation is called standard quadratic equation. So the standard form of a quadratic equation is x squared plus bx plus c is equal to 0. So this is the standard form of the quadratic equation. It contains both the first degree variable term and second degree variable term. So the standard form of quadratic equation contains both the first degree variable term and the second degree variable term. A, B and C can belong to complex number set, just as I said in the earlier slide, and A comma B are called coefficients. C is called constant term. And this quadratic equation has two roots. This quadratic equation can have two roots. So what is a root? So a root is something, if it gets substituted in this equation, then this whole equation becomes equal to 0. If we just take a number, and substitute it in the place of this variable term, then this whole thing on the left side becomes equal to 0. So if alpha, suppose if we take alpha as the root of this equation, then a alpha square plus b alpha plus c is equal to 0. So what we did is substituting the value of alpha in the place of variables. So if we substitute alpha in the place of variables, then this whole equation becomes 0, and we call such values as roots. So the number of roots that a quadratic equation can have, the number of highest roots that a quadratic equation can have is 2 roots. So a quadratic equation can have 2 roots. And b square minus 4ac is called discriminant. B square minus 4ac, this is b, this is the c. So b square minus 4ac is called discriminant. And the roots of the quadratic equation are given by alpha or beta, alpha comma beta. So the quadratic equation can have two roots. So its roots can be minus b plus or minus root d by 4a. So these will be roots of the quadratic equation. So this d here is nothing but this b square minus 4ac. This discriminant is denoted by d or sometimes by delta. So the roots of the quadratic equation are given as minus b plus or minus root of b square minus 4ac by sorry, this is 2a, not 4a, 2a, b square minus 4ac by 2a. So these are the roots of the quadratic equation.